Hello everyone and welcome back to Handmade Hero, the show where we code a complete game live on stream. We have been gone for 2 weeks because I accidentally broke the microphone. There's not really a lot more complexity to it than that. But I ordered a new one, and it even comes with the little bag of replacement parts and everything, just like the old one did. So we should be good to go now. But of course that means it's been 2 weeks without us working on this problem, so the problem that we had when we were last looking at our code base is still there. No one has magically come and fixed it for us, which is very unfortunate, and you know, what are you going to do? I wish we had a little magical code fairy who would come and sprinkle a little code dust on our code, and then when we came back it's like, oh hey, it already solved all the problems for us. What do you know? But unfortunately, we have to be our own code fairy, and we have to bring our own code dust, and do our own code sprinkling. So, I guess we'd better start sprinkling. I'm gonna grab my keyboard. So, today is day 303, and where we left off, we were trying to figure out exactly what we were going to do with sprite sorting. And I had just sort of finished determining that you could not really do anything with a uniform sort. You would at least need to do something more complicated than a uniform sort. And we sort of started to sketch out what it might look like if we did a full graph sort. I'm not sure we actually need a full graph sort. Certainly on the forums while I was away, people had sort of posted various suggestions. And there's a couple different ways we can go with it. It's unclear which way is the right way. One thing I do think is true, though, from what I can, from sort of my gut instinct, is one thing that I don't think is a good idea is z-buffering. And the reason I don't think z-buffering is a good idea is because I think we're going to have very semantic sorts of stuff that we need to do, such as keep the head of the hero on in front of the body of the hero, even though it should technically be behind it, or other stuff like this. And I feel like if I go with a z-buffer approach, I'm constantly going to have to fight the z-buffer to make these things happen, and I don't know that I really want to do that. So my hope is we can do a solution that isn't z-buffer, because I feel like that's going to be a little bit touchy, and as tweaky as all the rest of these things are, I feel like they'll be less tweaky than trying to fight with a z-buffer. That's my feeling on it anyway. And z-buffer is great when you have real 3D stuff. It's not so good when you have 2D stuff. You got to kind of come up with, sort of lots of little fakeries, fake tricks to try and make it so that the z-buffer ends up doing what you want to do, and doesn't do things you don't want it to do, which is hard when you don't have real 3D stuff that you're trying to, with actual shapes that make the z-buffer work correctly. So what we have, and we'll have to see where we left this here. Let's see here, handmade code. What we have in our renderer, and I don't know where I left it. I probably left it in the sort routine. Ooh, you know what? I should probably load the project file if I'm going to work on more than one thing. Or not. I forgot. That's something that I have to do. I have to upgrade to the new 4-coder. I'm a few versions behind on this machine, and there's been a lot of bug fixes. Anyway, so I believe it was in the sorting code where I left it down at the bottom here. Yeah, you can kind of see that I started to sort of talk about putting the sprite graph situation here. So one thing that Quartertron from the chat had suggested, he had played around with it himself on it, doing his own sort of research on it. He was suggesting that we do a sort of an interleave where we sort all of the Z sprites because we know that those can be sorted correctly, and then we sort all of the Y sprites because we know that those can be sorted correctly, and then we merge those together. And I haven't really thought through why that would solve problems or not. There are some reasons I can think of why it might solve problems, but I haven't really necessarily convinced myself that it would be correct necessarily. I also don't know, people were suggesting potentially that we could do sort of a poor man's BSP by using an insertion sort. Obviously, an insertion sort is a little bit different than the kind of sort that we're using here, where you compare items against each other, and you really only do that comparison at very specific times. An insertion sort works more like a tree, where you always sort of test the, going down a binary tree, you test each individual thing and try to find the place where it slots in. And because you're doing that every time, you end up sort of essentially building, what would end up being sort of a binary space partitioning type of tree for the data that's coming in. And so we might be able to leverage that in order to get the sort working more properly. Now, one of the things that I think might be kind of problematic about that, obviously, is how we would keep that balanced properly, because I don't know that it works for you really. You end up in an n squared scenario if you don't have some way of balancing that tree. So that would be, something that we would have to take into account if we were going to go that route. Now, obviously, it's very easy to do the solution that Quartertron was suggesting, but the thing that I just don't know is I'm not sure whether that solution is solves the problems that we have or not. And just to make it a little clearer, I can pop over to the current Milton dashboard over here. Where is that? That's in W. Milton. I have not updated to the latest Milton yet. I got to, let's see here. I have to do that sometime soon. Anyway, what day is today? So what this solution essentially looked like was, okay, we know that we have sprites that are sort of lying flat on the ground, right? And we don't know what height they're at, right? They can be different heights, but we know that they always point along the z-axis. And we called those our z-sprites, right? And then we had other kinds which were upright, they were facing, along the y-axis. And I guess if we're facing sort of more this way, I'll draw them more like this. Right, they're sort of facing towards us. And those are our Y sprites. Now what we know is that if we only had Z sprites, right, if that's all we had, then obviously we don't handle the case of interpenetrating sprites, right? So the sprites cannot be on top, they cannot intersect each other. So what that means is pretty much no matter what happens, the Z sprites could be sorted in Z, I believe, right? Because if you ever have a case where there's, sprites that are like in this sort of configuration, I don't think there's any way, because the Z is a constant thing, I don't think there's any way, unless this is on top of this, that you would ever want to see this first. So I believe if all you had ever was Z sprites, you could sort them exclusively by Z. I don't know that you need to sort them by Y at all. I have to think about that. But I'm pretty sure you don't. Because even for things that are right behind each other, as soon as one of them gets above the other one and thus should be potentially seen in front of one of them, it is actually higher in space as well. So they wouldn't even really overlap, if that makes sense. So kind of hard to say. But it seems like you could sort these by Z, and you can certainly sort these by Y, and that would definitely work, because there's never a case where moving a Y sprite in Z ever changes its sorting relative to another Y sprite, right? Because these are just in planes, and so either you're in front of or behind another one, and that will determine your draw order. So we can obviously produce the correct order of the Y sprites, and we can also produce the correct order of the Z sprites, because these two things independently work okay. So then the only question is, once we have Y and Z sprites in sorted order, how do we know when we need to draw one from either of the two things, right? Because that means I can have a list here of Z sprites, and then a list of Y sprites that are sorted, and I know that each of these should sort in a particular order, and each of these should sort in a particular order, and then I need to just know, oh, when do I start, I start rendering like some of these Z sprites, when do I render one of the Y sprites, right? And then once I start rendering Y sprites, when do I order a Z sprite again? So I need a way of picking what list I pick from, if that makes sense. And so, the theory, anyway, behind Quartertron's solution here was that if you use a scheme similar to the scheme we were concocting before, it will actually work for sorting in the case where you have done the sorts correctly for the two kinds that can be sorted first, and then only use it as the merge, right? So you only use it as the final merge step. You basically perform two independent merge sorts of things you know you can sort with a real criteria, and then you only use the sort of fakey, like hand-wavy criteria to merge those two lists together. Well, I like this idea. I think it's got some panache to it. So I am inclined to say we should give it a shot. I think it's kind of clever, and if it worked, it would mean that you could still use any kind of sort that you wanted to sort the Y and Z sprites, and then you would probably have to use a merge sort, I think, for the final pass. But like, for example, if you felt like you wanted to use a radix sort, for example, on the two separate pieces, you could, because now there would be an absolute single criteria for sorting those two lists. So it opens up more possibilities for you as well, which is just kind of interesting from an algorithmic standpoint. I don't know how important that is to us, but it's just kind of cool. And so I like this algorithm. I think it's kind of neat. And so I kind of want to see what happens if we give it a try. So let's see what that would look like. And also, don't forget, one thing that I have to do before we, call this whole situation done, even if it turns out this sort is a good sort. The other thing that I haven't really done yet is we have to ping pong sort of back over to the render side of things, because remember, I sort of hacked in the notion of the extents of these sprites, right? I did not really do a correct boundary sort of case for these sprites, and so we're not passing extents that are necessarily correct, which could give us some erroneous results, certainly. All right, so let's take a look here. Let us take a look. What I would like to do is, we've got sort of this existing merge sort here, right? And I think we have another merge sort here where we've got this sort of sort entry version, right? So what I need to do is I need to do something first where I'm going to get these things into separate buckets, right? Like I need to sort my Y's and my Z's. So I think I could probably do that by some sort of like when I do my merge sort, I do a first pass that puts these things into two separate buckets, which can then be sorted, right? Because I know whether something's a Z sprite or not. In fact, you can kind of see how we were testing that before. And maybe if this turns out to be too much of a pain, we can start to keep Y and Z sprites in separate buckets at creation time if we need to. So, but at the moment, I don't want to go making all kinds of systemic trouble for us upstream when we don't really know whether this is the thing we want to do. So it's going to be better probably to put something in here that could do it first. And then if we find that we want to optimize that away, we can be a little bit more aggressive a little bit further down the line. All right. So let's see. So here's a merge sort that merge sorts two things using the sort of this criteria, the is in front of criteria. So if we keep that criteria, then that means that really all we need to do is sort of have, we do the pre-pass, and then we kind of have we kind of have little merge sorts here that work on sort of as if they were doing this sort of a sort, right? And I'm trying to think if there's some way we can just use, I don't think there's really anything I can do to use this code really, because this code is trying to work on a single sort key. And while I could do that in the case where I didn't have to have this extra data routing around with it, I think I have to clone this routine for the most part, because there's no really other way to make sure that I don't that I track all the sprite bound information that we kind of needed, unfortunately. So anyway, here we go with our situation here. I'm going to go ahead and put this in, and I'm going to call this. Let's see. We'll call this merge sort, and I guess on sprite bound, I'm going to just call this guy merge sort y for now, and we'll see. I might be able to condense this code down a little bit more in the future, but for the moment, I'm just going to kind of write it out longhand. So if I want to merge sort by y, I want to make sure that my sprite bounds, my minimum y is actually the y that's closest to me. So I want to make sure that if entry A, these things are drawing from back to front. So entry A, it needs to be behind entry B, if that makes sense. So if entry A's ymin is like less than entry B's ymin, then we would need to swap, because if entry A has a y that's closer to us than entry B, then it needs to draw second. So we would do a swap, right? And similarly here, where we're kind of doing our partitioning, same thing applies. In this case, we have a situation where we need to know who we're going to take first, and so we want whoever has the greater ymin, because whoever has the greater ymin is the one who needs to be drawn first. All right. So that's how we would do a sort for the ymins, and we can do the same thing on the sort for the z's as well. I'm gonna clip this out here for a second. This doesn't. Oops. This is extraneous older code we were playing with. So here's like our merge sort in y, and the exact same thing would work for merge sort in x, right? But for the time being, well, of course, the other thing I have to do is I do want this guy, this merge sort, to work with the sprite bound. I guess in that case, maybe this would have been smarter, huh? Start with one that already works with the sprite bound. So yeah, and the other thing I could do if I want to here is I could say is in front of sort key. Why is this guy still doing sort key? Oh, because we still just call it sort key. All right, that's fine. So in this case, we've got is in front of sort key. What I want to do here is just I could still say is in front of y. I could still do it like that if I wanted to, and so that we can basically keep this same routine. And that would be our merge sort y. And we'd also have a merge sort x. I'm sorry, merge sort z. And you can kind of see it's a little annoying, right? Because it's like it's exactly the same thing. And I'm not sure, we'll have to think about whether we can condense this at all. Obviously, if you're a templatizing sort of person, you could condense it on a template. Of course, that still does generate duplicate code. So it doesn't end in actually condensing it in the actual output, but it would make it more concise to read. But there might be other ways we could get this to condense in actuality. And I don't know whether that's the case yet or not. But either way, if we do have a merge sort y and a merge sort z, then all we need is a way of doing that sort, the is in front of part. We need a way to do that for these two criteria. So we need a y and a z. And when we have is in front of a and b, that's a is in front of b. A is in front of b if A has a z-min that is less than the z-min of B. I'm sorry, y-min. Right, that would mean that A is in front of in Y. And the same is true for Z, only the sense is reversed, right? Because Z comes up at us on the screen. So essentially we're going to have a swap here. And we don't have a Z-min, we only have a Z-max. So we're going to be looking at something like this, where we say like, okay, the result is if the Z-max is greater than the other person's Z-max, then it's in front of. So that now we would have our two different merge sorts that we need, right? And those will do the sorts of the two separate buffers. And then we would have to have one merge sort that merges all of them together, right? Now, in the case where we have all of them together, we still sort of have the same kind of a merge sort scenario that we had before, except I think we don't have to really do the special cases anymore, meaning I think we can just sort of do this, do the two buffers and then do the merge of the two buffers. So I'm pretty sure that if we go ahead and say merge sort here, I should be able to do a thing where we can make this work. So what I need to do first is I need to partition this buffer into two pieces, right? One of which is going to be all of the Z sprites, and one of which is going to be all of the Y sprites, right? So unlike the previous merge sorts that we did, where we partitioned the buffer into like two halves, because what we're trying to do is just sort homogeneous things, here we've got a heterogeneous grouping of things. So I first need to pull out like all of the Y sprites and all of the Z sprites and sort them separately. Then I can do my merge. So I think what I would do here is I would say, since we have a temp directory that we know, a temp directory, that's good, a temp buffer that we know can hold as much as we have in our main buffer. Obviously, I could move all of, say, the Z sprites in there. And then I could move all of the Y sprites so that they were compacted in the original buffer or something like that, right? So let's try to write a routine which does that, which produces in sprite bound star first, sprite bound star temp. Let's just move all of them over into one and then, deal with the other. Okay. And again, like I said, this is not going to be the most efficient thing here, because probably if it turns out that we really care about how this is performing at the end of the day, we would probably want to do something where we just keep these guys separate to begin with and then merge them later, rather than handing the renderer a buffer with all of them in it and having it have to disentangle them, since it's pretty easy for us to know at output time which one's which. Okay. So here we go. I know that I'm going to do basically this same loop, right? I'm going to loop over everything in the buffer. And here's my first, whatever you want to call it, my first sprite. I know that my first sprite index, that's the one that I'm on. And I know that I could say, if was a Z sprite, or is a Z sprite, I know that I could say, well, if this is a Z sprite, then I want to move it to the temp directory, right? So I want to be able to say like temp, or I guess Z count ++ equals me, right? And I'm just kind of sketching out what this would look like. Now, what would happen is, as I start to move things out to here, and let me just draw this for you really quickly so you can kind of see what I'm doing. I've got this buffer, and inside here are like all different kinds of things. So there's a Z sprite, there's a Z sprite, there's another Z sprite. Maybe this was actually two Z sprites back to back, or something like this. And I want to move the Z sprites out into this empty buffer. Well, coming through here, anytime I see a Z sprite, copying it out to here is not particularly hard, certainly, right? But what I do have to do then is remember that this is now a hole in the buffer, right? So what I need to do for the simplest possible case, which might not be the most efficient, but for simplest, is the next time I find, right, a Z sprite that, a Y sprite, I need to copy it up to here. So I basically need to compact these values. Does that make sense? So I sort of need two concepts here. I need a sort sprite bound, or I guess I should say, I need a Y count and a Z count. And then we've got like the index that we're actually on. And so what I would do here is I would go, okay, I've got my sort sprite bound. That's like this one, whatever this one is. And that's going to be the first buffer plus the index. That's the one I'm looking at. And so then what I want to do is say, well, if it's a Z sprite, then I want to move it to my temp buffer and increment the Z count. Right? And that leaves a hole wherever I am. On the other hand, if it's a Y sprite, then I want to compact it into the most earliest possible unused space in this buffer, which of course is just whatever the Y count is, and then increment that. Now this may copy it onto itself. If we haven't seen any holes yet, it will copy it onto itself. But that's okay. We don't care. We could early out that if we want to, but who cares? Again, the time for optimizing this is not now because we don't even know if this is something we want to use. So we'd rather do is go for something that works correctly first and then worry about optimizing it later if we verify that it is actually a valid approach to the problem. So at this point, when I exit here, I now have my first buffer and my temp buffer. My first buffer has all of the Y sprites in it, and my temp buffer has all of the Z sprites in it, right? And so what I can do now is I can move, again, this is not very efficient, but, you know, ideally we'd just have more temp memory lying around. Like we just have, and that's probably what we should do. But just because, hey, we're writing some of this code, I'm going to even put a do in here, do Casey. This is really just for funsies. We should probably just pass in more temp memory. What I can do now is I can copy that sort of the Y sprites onto the end of the Z sprites, or the Z sprites onto the end of the Y sprites, one or the other. And that way I still have a regular temp buffer sitting around if I needed one. But, wait, no, I'm an idiot. You don't even need to do that, now that I think about it. Because what do we know, therefore, has to be true? If what I just did is I separated out this into some number of Y sprites and some number of Z sprites, what I know is the unused portion of the Y sprite buffer is exactly the right size to be the temp buffer for the Z sort, and the unused portion of the Z sprite buffer is the exact right size to use for the temp of the Y sort. Right? Because this has to be this size. These were both the same size to begin with. So however many I stuffed in here, that's how many I didn't have at the end of this one. Right? Because it was full before. So whatever I pulled out, that empty space is the same size as the number I pulled out. So now I should be able to call merge sort with cleverly crafted pointers so that it doesn't actually ever have to move anything around again in this first merge phase, right? So now I can call my other merges, right? Here's, right, which are basically just the standard. Now these are the standard merge sort that we actually had, the same one we had before. So I've got my Y count. It's going to be first, and instead of passing temp, I'm going to just pass temp plus Z count. So I'm going to have that end of the temp buffer that it's going to use there. And then for the merge sort in Y, I'll pass it the Z count, which is how many are in that temp buffer, and then we'll use the first plus Y count, that end of the first buffer, as the temp buffer there. So now I have my Z's and my Y's in place sorted, because remember, we kind of did the inefficient thing where we did the sort where it copies it back here, right? Which honestly, you know what? We could get rid of that now. we don't need to do that copy anymore. Well, you know, I don't, only on the last one. See, this merge sort's recursive, right? So I can't really, I'll leave it in for now. That's too bad. We could go get rid of it, right? We probably should, but anyway. So after I merge sort these, I've got first and temp are pointing to my Y and my Z sprites respectively, right? And so now I need to write the thing that will merge them together. And in order to merge them together, the problem is this part, I don't know if we can be as clever as we were with the other part, where we just kind of use those ones. Because this, I believe, assumes it can look at two things and have space to write them all contiguously after the fact, right? And I don't know how we would really do that. It doesn't seem pretty, right? So I feel like this is a place where we're going to need to do more of a copy here. Now, what's hilarious about this is if we could just tell this thing, oh, actually, this is a copy, isn't it? So if this is a copy, that means that the other buffer still has all the stuff in it. So that means technically, even though we told it to sort in here, an exact copy of the sorted thing is actually also sitting in here. So we don't need to copy it back because this just did. Okay. Now the only question I have there is what happens in this case. So that won't be true in these ones exactly. So, you know, we would have to make sure that for the Z count, let's say, so everything should end up in buffer first. So let's say in the Z sorting one, what we would have to do is say, well, okay, you know, in the case where we have quote unquote no work to do, we would still need to copy it to the temp buffer, right? Like we'd still need to do a copy to the temp buffer, even though we don't really need to if we were just returning the value, right? And the same is true here. So, you know, we've got entry A and entry B, first and first plus 1. We need to do, like, you know, just first 0. You know, technically. Obviously, we don't actually need to do that. Because we could, the other thing we could do here is at the merge sort stage where we do merge sort Z and merge sort Y, at this point we know that the Y buffer is the one we want. What we can do is we could say if, you know, the Z count is less than 3 or less than equal to 2, then we know that we have to do that copy back because it will not have done the copy back for us. Any other case will run through here and it will do that. It will have left the two buffers the same. So in this case, we've got a merge sort on Z. We know that we're doing, wait. Why do I have these backwards? Should look like that, right? We should do a merge sort Y on the number of sprites we have in Y, right? And then we say, okay, we're doing that in our first, because that's where we put all of the Y sprites. I should also probably do a thing here. How do we tell if it's a Z sprite? We just do if they're equal, right? So we want to say, okay, if this sort key, this sort key. So if its Y min is not equal to its Y max, then it's a Z sprite. Yeah, so I want to merge sort in, using Y criteria. However many Y sprites I have, they're in the first buffer, and they are temp plus Z count. That's how many. I'm sorry, temp plus Z count is where the temporary area is in the other buffer that's not being used. Similarly, we want to merge sort by Y, merge sort by Z, the temp buffer, and we want to pass the unused region of the first buffer for that. Now, in the case where the Z count is less than 2, then that buffer, that first Y count needs to have, the temp stuff added into it, right? So we kind of need to do this sort of a thing here. I guess we could almost do it this way. So if Z count equals 1, we copy 1, and if it's 2, we copy 2. Anything else and it would have just worked. So I think that's all we need to make sure that our buffer is correct, right? And then we know that what we've got is we sort of have this notion of our two sprite sets. We know we have, well, and I guess we can use this same sort of looking thing here. We've got in half 1, in half 0, and in half 1. What we have here is first and first plus Y count. Those are our two things we're coming from. And then the end is in half 1. The end of this buffer is in half 1 plus Z count. Oh, but that's not even really necessary, I guess. Really, this is the part we wanted. This doesn't have to happen. Okay, so we know in total how many we had, right? And we know we're reading from half 0 or half 1. Oh, looks like I did need those. Never mind. There we go. It's just that part I don't need. All right. Okay. So I'm looking at the temp buffer, and I'm saying that's what we're going to have to use here. Oh, although I can get rid of this too, right? This not really necessary for a ping pong thing. That I can get rid of now, because I can just, if I want to, instead of using the first buffer, I can just use the temp buffer, right? So instead I could say, oh, okay. After I do my merge sort Y and my merge sort Z, instead of using first as the primary buffer to pull from, let's just use temp. So in half 0 will be just the temp. This will be temp plus Z count. And then, yeah, then we need to just reverse the sense of this. Yeah. Okay. So now we can just pull out of the temp buffer and write into the first buffer originally, so we get rid of that extra copy at the end, because it's just sloppy not to. I mean, it's not like an optimization really. It's just we have to go one direction or the other. We might as well pick the one that doesn't have an extra copy. It's no skin off our back. So we start at temp and temp plus Z count. We know we have to end at the total count number, right? And then when we're reading from these things, I feel like these, why, I don't even know why these are different here in half 0. Probably because I typoed them earlier. So there we go. All right. So then we come through and we say, well, if read half 0 has bottomed out, we always read from half 1. If read half 1 has bottomed out, we always read from 2. Otherwise, we do the test, and we pick from whichever one gets the is in front of, comes back, right? Now, what's a little bit weird to me is, yeah, okay, we passed them in the opposite order, so that looks right. Okay. So I think that's basically it. The only thing that we really have to be aware of here is that really, first of all, this is first plus count. We're writing to the first buffer. We don't, to do this merge comparison can be simpler now, since we know which sprite is a Z sprite and which is a Y sprite, right? So yeah, excuse me. Okay, so our merge sorts, right, since they're recursive, they need to call the respective version of themselves. So the merge sort Z needs to call the merge sort Z, and the merge sort Y needs to call the merge sort Y, for obvious reasons. There we go. And so now we've technically implemented this, but hey, that was a lot of gyrations there. We probably need to like go through this code a little bit more carefully, and well, I think that's the end of the sentence, actually. We probably need to go through this code more carefully, because we probably made some mistakes in there. For example, there you go. So this is our little check at the end here, and I'm not sure. I guess I wanted to just kind of see what it did first before we were going to assert on this. Let me see here. So let's see, first of all, if we're anywhere close. We are sort of anywhere close, actually. So that's definitely better than what we had before. That much is clear. But it's still not, we still got a ways to go, certainly. All right. Okay. So let's start playing around with this a little bit more carefully here. What is this? Is in front of... So I guess the only slight issue here is that I don't really know. I guess this is something we can use to always check. I'm not really sure. But anyway, yeah. That is neither here nor there. I would like to go through this a little more carefully first before I start to figure out whether or not we have bugs in the actual comparison stuff, which obviously we have to have at least one, or the sort just, or this idea just doesn't work as a sort. But I think it probably is way premature to determine that. Anyway. So we've got about 15 minutes left, so I'm going to dive in here and see if I can determine how well this is working. So first of all, let's start by jumping on in here. Okay. So what we're doing here at the very outset is we're taking a look to see whether we have Z sprites or Y sprites, and we're sorting them in here. And you can see a bunch of people are going into Z and Y and so on, right? And so let's take a look at what this looks like after we're done. So Z count, Y count. And that's probably what we would expect, right? Because every floor tile is a Z sprite, whereas the only things that are Y sprites right now are actually occupied tiles, like a tree or the hero or something like that. So we would expect there to be dramatically more Z sprites than Y sprites, and that is what we saw. So that seems okay. right? That seems like a reasonable thing. If I take a look at, well, actually, you know what I should do? There's really no reason not to just verify, right? So let's go through from 0 to y count and assert that the sprite is the kind of sprite we think it should be. And I should probably also put up here and his ZSprite function. I suppose I could do sprite sort. What was the thing that we were passing around before? Sort sprite bound. Sprite bound. Just sprite bound. Okay, so yeah. So this way we could say, like, okay, if it's a ZSprite, I'm going to assert down here. That in both cases, we have no ZSprites in the Y and all ZSprites in the Z. Right? Okay. So this way, hopefully that gives me a little bit of protection there to verify that they all got sorted into the two buffers correctly. So that seems good, right? So now, I could also do a thing that's like verify buffer. Like I could do this. And what I could do here is say, well, okay, you'll give me a buffer, and then this will say, I want to assert that is ZSprite of this buffer, of everything in this buffer, equals the ZSprite value you passed me in. So if you want to verify that they're all ZSprites, you'd pass in true. If you wanted to verify they're all Y sprites, you'd pass in false, right? So then that way this could just be verify buffer, Y count first, false, and this could be verify buffer, Z count, temp, true. Right? So that would verify those buffers for us. After the merge sort, we could verify again. So after we do this hocus pocus right here, we could say, oh, yeah, after we grab these out, let's make sure that in half 0 and in half 1 are what we think they are, right? So in half 0 is supposed to be all the ZSprites sorted, right? So that should be a Z count, and this should be a Y count, so it should look like that. So yeah, right? Does that look right? Hopefully. So let's re-verify that as well. And so now we can at least verify our two sort of primary, that coming out of here, we at least didn't do any of our sort of magic shuffling wrong. Like everything's in the right place according to these verifications, right? And you can kind of see what, all this is doing, right, is it just comes through here and just issues a ton of assertions. Right, there's nothing to it. All right. So anyway, we've got these verifications in here. So at the end of this, we know that we're at least sorting fair sorted things. And then we would come through here and we would say we need to merge these guys together. Now, my suspicion is that since we now are working with these sort of sorted, these planar sorted striations, at this point, what we would probably want to do is make sure that we just always sort the, well, I feel like we still kind of have a little bit of an issue here with the merging. So I feel like we're gonna need a little bit of a better merge to make this go correctly, because right, we're kind of like working our way up in planes of z and forward in y. So we're kind of like, you know, doing this process. And in order to know which sheet to pick next, I feel like figuring out whether the two things overlap isn't necessarily going to be what we need, if that makes sense. So I think I need to think this part through a little bit more. I don't know exactly what Steve did. I don't know what Quartertron did. Well, he might be on the chat. I don't even know. Is he on the chat? I haven't been watching. Is Quartertron out there? Anyone know? Anyway, so point being, we've got a situation, right, where we now are basically moving, you know, if we looked at this from the side, sort of, so the camera is like looking down here. What we're essentially saying now is we're moving a plane this way and this way. And every time we get to somebody, we get to a new plane, we have to decide, is this new plane the one we should be drawing next, or is this plane the one we should be drawing next, right? And so it seems like, I don't know, it seems to me like that's a hard decision to make. I wonder if there really is going to be a way for us to make that decision in a way that, like, if we could make that decision properly. I guess the thing that is a little weird in my mind is, like, if we could make that decision properly, why couldn't we have just sorted by a single criteria? So it does seem like a little wonky. Like, it does seem like I'm not sure that this will actually work. But well, hard to say. So anyway, let me take a quick look at what our current thing is here. So we have both Z sprites. So we never have this both Z sprite condition, right? That's never going to happen now, or at least it shouldn't ever happen now, if that makes sense. Although I guess it happens in the sense that not build sprite graph, this thing here, the sort entries, when it goes to verify, it's going to call the is in front of. So, you know, that will happen. But so we have the both Z sprites thing, and that's never going to happen in our actual testing. So in the cases that we're talking about now, that's always going to be false. And then we're going to do the A includes B and the B includes A bit. And in this case, like I said, so we're never going to be able to have two Z sprites. So the Y min, Y max, we could, for example, ensure that we always pass a Z sprite in a particular order here if we wanted to, right? But anyway. So when we figure out whether we need to sort by Z, we were previously saying if they're both Z sprites or there's some overlap. So I guess that was saying, like, essentially, if our Z overlapped the Y of whatever this thing, you know, even if it was a Y sprite, if the Z sprite sort of was overlapped it in Y, then we would still sort by Z. Otherwise, we would sort by Y, right? And so let's see what this is saying here. So that's saying we'll sort by Z. We will look at the Z maxes and we'll move them. Otherwise, we'll go by the Y mins. And that is how we were doing it, right? Here we were doing Z max. I suppose the other thing we should do for verify buffer, now that I think about it, let's verify that they're sorted correctly. So we could also do something like this. Let's assert that buffer index sort key. Oops. Let's assert that buffer index -1 sort key. I guess technically it's this way around, right? So the one we're on, let's assert that it's supposed to be in front of the one that came before it. That way we'll also verify the sort order of our staging buffers, right? Okay, so something got messed up. Before we get to the magical part of the merge, I messed something up. And you can kind of see how I was approaching this problem, right? There's just so much data flying around that rather than try to inspect a lot of it at the debugger at the head end, I just decided to write some code that would do some testing, right, on that. And this is why a lot of times, it doesn't happen so often, thank God. But in the past, everyone was saying, what do you think of test-driven development? And I, think I said a bunch of stuff about like, well, you always have to make a decision about whether it's going to save you time or cost you time. While this isn't technically test-driven development, you'll notice I am adding sort of more complicated tests here. And the reason for that is I'm doing exactly that trade-off, right? I'm looking and saying, I think I can save myself some time here by writing tests in code because I think those code tests will find the bugs faster than I can find the bugs without the tests, right? And that's kind of like a thing where I'm always making that sort of trade-off in my head where anytime I have a piece of code I'm trying to debug, I'm always thinking, would it be more valuable to have tests here? Is that going to be the shorter way to go? Most of the time the answer is no in games, but sometimes the answer is definitely yes. In this case, I think it was going to be easier to do it this way. Now, I don't know if we actually found a bug or if I just wrote the test wrong, right? So we first have to actually get the test working. That's another reason test-driven development is always a little bit costly, but still. So let's take a look at what's going on in here. So let's take a look at the first time through this loop and just make sure things are generally kosher. So here we go. Here is with index 2. Oh, you know what? That should be greater than 0. So here we go with this test, and you can see that we're at least passing occasionally. So it's not like the test itself is complete nonsense. But here we have failed. So let's take a look at what we returned here. This may be the case of two things that are identical, and so in that case we would also have to do the same test. All right. So in this case, we have two sprites who both have an equivalent z value. So, I guess in this case, I wonder if we do want to still use, in the case where we've got equivalent z values, if we want to sort them, we may still want to do that sort. So I guess now I think about it, maybe I should be doing the same sort in all cases, right? So maybe I shouldn't actually have done it this way. Like maybe I should leave the old way of doing it where we still do is in front of in both cases, right? Yeah, seems like a fair thing. So instead of doing so that way we get that extra sorting of Z sprites where they'll sort by Y if their Z's happen to be equivalent. That seems pretty reasonable. So let's see. Merge sort. What do we want to call this? What do I want to call this? Because in here we sort of call, we call this merge sort, but this is really like, I'm going to call this a separated sort, and the other one the merge sort. Because the other one's the one that's actually doing a merge sort. And then I'll try saying, okay, what if we just get rid of this and keep doing it the other way around? So here's our merge sort. It is in front of in both cases, right? And then we don't have this anymore. All right. So what do we have here? Let's see where. So now, like you notice, we passed now that we're doing that kind of sorting, where we're actually still keeping our Y's and Z's correct there. So our is in front of failed here on somebody. Let's see what it said. So in this case, we have somebody who is closer to us in Z, coming second, which seems correct, but lower in Y. But it's a Z sprite. I guess only one of them is a Y. Only one of them is a Z sprite. That doesn't. I'll be honest. That's a little confusing. I'm not sure I can immediately tell why entry B wouldn't be in front of, because it's also higher. I feel like that wouldn't matter. I want to see what the visual results of this are at the moment. All right. Getting a lot of flashing there, so that's not great. Well, I don't want to go too far over time, so I'll put that back in for now. And we will go to the Q&A, and then we'll take a look at this tomorrow. And we can also ask Quartertron if that was a faithful implementation of what he had tried to do, because I don't actually know. Oh, Insobot is here. It would be great if Insobot had a question for the Q&A. I always love his questions. Or her questions? Its questions? Is Insobot gendered? Or is Insobot like asexual? Stay thirsty 90. I'm going to skip that question for a minute since it's not related. Rome says, I'm trying to take a different approach using the projected sprites on the screen to sort and using the min-max Y values up as the depth sorting key. You are trying to take a different approach? So does that mean you have not taken that approach yet? Or rather, you have not gotten that approach working yet? Or does that mean you have gotten it working yet? Because I was going to ask, how did it work? But maybe you don't know how it works yet. Working on it. Yeah. Well, keep us posted. I'm going to ask Quartertron what he thinks of our current implementation, or whether that's whether that's similar to what he tried or not. I feel like, since no one's asked a question, I'll take the question of what is a full stack developer. A full stack developer is what people just used to call a programmer. It's somebody who like knows how to program. But nowadays there's kind of like this secondary aspect of programming, which is like there's some people who kind of just know how to like write JavaScript or something, but they don't really know very much about how like a computer actually works or something like that. So they can't necessarily go work on like if there's this, some kind of underlying database technology that you have the source code to, they wouldn't be able to necessarily go like modify some of it, right? Or even know if it was working right or not, right? Because all they know is like they issue a SQL query and something comes back, and they don't really have any idea how it's like magic. Like, they wouldn't know necessarily what was going on under there. And so I think typically what people mean when they say full stack developer is really what I would have just called a programmer. Somebody who I could tell to go do something that has to do with programming and do it. As opposed to just being like, I don't know, man. I only write the like web page or whatever. And so I think that's kind of a newer thing, and it's basically because, well, nowadays there's so much stuff that gets done in software development. You end up having tons and tons and tons of work for people who maybe aren't really programmers in the full, like, know all the ways in which, know all the things that you might expect a typical programmer to know. Then yeah. And I guess in theory it could go the other way too. Like if somehow you're somebody who does know how to write a SQL server, but doesn't know how to write JavaScript or something, you also wouldn't be a full stack developer, because if for some reason you're like, I couldn't go figure out how to write the JavaScript for a web page, then, well, that's not the full stack, right? That's not the full end-to-end part programming that happens. Poo shoes. Won't sorting fail because a lower Z sometimes needs to be drawn on top of a higher Z if a Y sprite overlaps them? See reference image. That is a very good point, Poo Shoes. Yeah, I like that. That diagram is pretty good that he posted. Maybe I'll draw that into the stream here. So Pushus drew so it's basically A, B, C. Here's the side view. A, B, C. And so from the camera, in this case, right, we've got something that looks like this, where here is A, and here is C, and here is B, and this should be behind, right? This is the furthest most back, this is in the middle, and this is in front. But this has a lower Z value than this. So it does seem like, yeah, it does seem like this approach wouldn't necessarily work. Because we don't know. It does seem like it comes back to the same problem as before, right? Which is that we still need to do the cycle. We still need the cycle. So we'll ask Quartertron about it and see if he maybe had something cleverer there, but I think you may be right. Which still leaves us at the graph side of things, which is fine. That's what we were going to do before, but it would be nice if we didn't have to. Biblo, at the start you mentioned insertion sort and potentially automatically getting a binary tree representation of the sprites. What happened to that idea, assuming I roughly understood correctly what you've done? So that one, and we could try writing that one tomorrow too, assuming that there isn't something we missed in this one and that this is in fact not a viable algorithm. The way that one works is by saying, well, let's suppose that we are taking something like this and we go, okay, you know, we've got B and B becomes the top of our tree or something. We get A and we see that A is behind B, so it goes on this side, right? And then we've got C and C is in front of B, so it goes on this side. And then if another guy wants to slide in here, right, we would go, well, he's on this side of B. Which side of C is he on? Well, he's behind C, so he's, you know, this is D or whatever. So he's here or whatever. So the insertion sort does lots of comparisons based on those splitting planes as you go down. And the problem with this approach, I think, is that I don't think in the end, I feel like it's going to just degenerate to the same problem as this one, which is that unless you actually split things up in some way, when you're not sure what should happen between any two things, you'll end up in the same problem we ended up with here. So I'm suspecting that the graph approach is the only one we can really do, if that makes sense. How do you transform the sprites from world to screen coordinates? We do that, I mean, we just do that with a standard or very, very basic orthogonal projection. It doesn't really do much. All right, I think that's it for today. So all right, we've got a few more things we've tried here. I think we may still, like I said, it still kind of looks to me like we're going to have to do the graph sort, which is not a big deal. You know, we'll write it, we'll see how it goes. I don't think it's going to be a huge deal at the end of the day. Yeah, sprite sorting is complicated. What can you do? It's the kind of thing where you've got a very semantic problem, and semantic problems are always kind of a little bit nasty, right? But anyway. Like I said, not a huge deal. We'll keep playing around with it, and eventually we'll get something that we're happy with. All right, thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along at home, you can always pre-order the game on handmadehero.org. It comes with the source code so you can follow along at home. We also have a forum site if you want to ask questions, a Patreon page if you want to support the video series, a schedule bot that tweets the schedule at you if you want to catch us live, and an episode guide if you would like to catch up on old episodes. That's about it for today. I will be back tomorrow. I believe we're 5 p.m. Pacific Daylight Time tomorrow. Until then, I hope you guys have fun programming, and I will see you on the internet. Take it easy, everyone.